Spatial Daylight Autonomy, or sDA, is a yearly metric that describes the percentage of space that receives sufficient daylight. This analysis type is a precise metric that must meet the required parameters in order to determine the building's daylight performance. It describes the percentage of floor area that receives at least 300 lux for at least 50% of the annual occupied hours from 8 a.m. to 6 p.m. on the horizontal work plane located 30 inches above the floor. Annual sunlight exposure, or ASE, refers to the percentage of space that receives too much direct sunlight, that is, 1,000 lux or more for at least 250 occupied hours per year at the work plane height. This amount of sunlight can cause glare or increased cooling loads. cove.tool's methodology uses an LM83 approved method and conforms with LEED version 4.0 requirements. The ray tracing engine improves speeds by 500 to 1,500 times by employing new statistical methods, machine learning, and a parallelized calculation on our back-end server environment. This allows us to have multiple 3D analysis types calculated simultaneously for every floor. Environmental conditions are based on the Trigenza sky dome, constructed from the weather file with 576 subdivisions. To speed up the simulation, we keep the reflectivity percentages, or materiality, fixed with the following assumptions. Floors have 40% reflectivity, interior walls 70%, ceiling and roof are also 70%, and exterior facades, including shading devices, mullions, light shelves, etc., are 50%. Exterior walls are 35% reflectivity, and outside ground is 40%. This allows any user to construct a realistic simulation and avoids cheating the simulation with incorrect inputs. These are also the correct settings for a LEED daylight analysis by default. You can alter the analysis settings to change visual transmittance or edit the grid size. A larger grid will run faster, but provide lower resolution results. Using daylight simulations early and often in the design process helps keep human comfort, usability, and energy efficiency at the forefront. Balancing sDA and ASE values guides the design towards a useful middle ground between daylight availability and visual comfort.